this video, we're going to look at a very simple production model. What we want to do, we want to assemble a shaft and a key, which are both manufactured, machined or sourced externally, with dimension and tolerances, so it will be a diameter and a standard deviation in terms of tolerances. The same thing happens for the key. We want to assemble those together and measure them and see how many of them will actually fit into this gear, and knowing that all these parts will have their own dimension and tolerances. So we have to first set what these dimensions and tolerances are, and we're going to Home and Resource Manager, and under Event Analysis Static Function we set those dimensions both for the shaft. They're all three modeled by normal distribution, and if we look at what one of these actually looks, we are looking at defining a cumulative normal distribution, but in terms of probability we use a random value, so that we'll have variability, complete variability in our simulation. And then obviously when it comes to mean and standard deviation, we set the measures. So all that follow the same pattern, and we've got a dimension of 28003 for the shaft, 4005 for the key, and the gear is 32.2008. So these are our functions that we set, and then the first block is a simple standard block, and we can use that to just add the shaft and the key together. So obviously we don't know which value will be picked up, because then the actual probability, it was a random variable. Okay, so we assembled those two parts together, and we passed on the result to the next block. The next block is a conditional block, and the next block basically looks at what comes in, and it checks. We can put any criteria we want, but what we are interested in is that the sum of the shaft and the key is lower or maximum greater equal to the gear. And we put a condition. If the condition is true, we go along the truth path, and that represents our production. So those units will be absolutely fine, be acceptable. If the condition is false, so if it doesn't fit into the gear, those will be part of the waste. And we'll also pass on the one along the waste path. And then we look at the storage block. And the storage block, we just, for both of them, we just normalize the results come in. So we'll be looking at, based on a number of simulations that we're going to carry out, we'll be looking at how many of them go through the production path and how many of them go through the waste path. Once we've done that, we can simulate. And we simulate, say, 10,000 times without using the seed, so we'll have a total variability between one simulation and the other if we wish. Okay, so we got the results. And we can show the formula. The formula here represents the result of the last simulation, okay, but this is the normalized results, and we can say that 97.76% of our unit end up in production, and 2.24 ended up in waste in the recycling bin. And we can also look at a chart if we wish, and again we got the same result. 97.8 is production and 2.24 is waste. And that's it.